the top chord of my deck, or like what they call the decking support surface, I guess, I have it parallel. I swear I have it parallel. I've checked all the nodes and made sure they have like the same, I guess, Y and Z values. But I can't seem to create a physical member that spans like the entire deck. So when I try to follow your basically your tutorial on adding the loads just to find by between like 6 and 9 feet or whatever it is, I can't do it because, you know, the physical members are split up. So what I've done was, you know, my members, or, you know, pieces of the members, I can apply it, assign it to the individual members, and then kind of tweak the loading to get it around 2,400 pounds or 2,450 or something like that. But I noticed the kind of diagram or display of the loading, when I do it this way, seems to concentrate over where I have tension members basically attached from a superstructure downwards. Like, it's not evenly spaced out. Like yours looks evenly distributed, but mine over the smaller members that aren't as, you know, some are larger triangles and then it gets smaller in some places, and over those areas it looks like it's super concentrated. I don't know if that sounds familiar at all, or I don't know if it distributes the force based on the individual member lengths, or what, like it splits the load between, if I have 10 members selected, if it distributes it evenly among 10 members regardless of those members' lengths. I'm just trying to figure out a way to correctly model this loading if I'm not able to get a physical member to span the whole length.
Well, I hear several questions in there, so let's start with the first one on physical members. There are several issues that need to be resolved in order to make a physical member, and one of the things, now you're saying they are completely collinear and interconnected. That sounds like that's a situation you have. Well, what I'm going to ask you to do is to go to your model and take a look at where your local axes are pointing. If your local axes are not pointing in the same direction, it's not going to let you do it. So here what I can do is I can go up to my structure toolbar at the top, and what I'm going to turn on is this one, Symbols and Labels area. And what I can do is turn on the beam orientation, and then I'm going to click OK. So now if I zoom in here, and mine has a lot of members, so it's going to look a little confusing. Basically, what you need to make sure of is that your local axes are all identical in order for something to be, you know, connected or assigned as a single physical member. If they are not pointing in the same direction, say your local z-axis is not, local x-axis, that's the one along the member leg. If that's not pointing in the same direction for all of your members, it's not going to allow you to form a physical member. So if you want to use the physical member approach, I would definitely encourage you to just check which direction your local axes are forming. Also, you're going to need to make sure the same section is assigned to every single member. Say I have a W8 by 10 here and a W12 by 19 there. It won't let me join a physical member. So that's the first one, is just check your local axis system if you do want to use the physical member approach. But like you said, you don't have to. That's probably maybe the quickest way to get this type of loading in to investigate different scenarios. That's why we went with that with the training manual. But you don't have to. You can always just do your single member load area. Let me clean up my display and turn these off. You can always just assign a member load. So if I go to my General tab and my loading area, let me go ahead and show you probably what you use. You probably use member load.
Yes, ma'am.
Now for member load, what I'm going to say is it looks like you're looking at the graphical representation of the member load, and I'm going to caution you, don't take that literally. There may be areas where it looks more dense than others. It doesn't mean that there's more load on that particular area. It's just a graphical representation. So if you're ever concerned about that and want to see your load magnitudes, I would look at that more than the graphical representation of the arrows. I can, again, if I go, this is a very handy toolbar up here that's going to display information. I could just turn on my loads button there, and do I have values? Okay. So that'll turn on the representation of my loads, and then let's turn on the actual load values. Go. Okay, so if I go back to this area, I can turn on load values. And then I can click OK. So I would say look there, and if everything looks the same, you'll see here almost on mine. See, it looks like I actually have a little bit of an overlap there because it looks kind of dense. It's not. It's just a representation. So I would say look at the load values instead. And if you did use just this member load option, it doesn't matter how long the length of your member is. So if I say put 50 kips per foot along this member, it doesn't matter if the member is 1 foot long or 10 feet long, it'll be 50 kips per foot. Or if I apply the same load to 2 different members, one's 1 foot long, one's 10 foot long, it's still going to be just 50 kips per foot on each one. As long as I leave these 3 values set to 0. If I leave these 3 values set to 0, it'll be along the full length of the member.
Okay.
So, but yeah, you can see mine here. It looks a little weird right there. It's just graphics.
Yeah, just like mine looks over like critical areas, though. So I wanted to be sure.
Okay, I would turn on your load values just to kind of double check that.
Yeah.
So, and you know what? Does this work? Yes. Okay. If you also take your beams cursor and double click on a member, you can kind of see the loading on it. Can I see a graphical? Oh, I thought I could see a graphical representation, but I can't. No. Oh. Okay. Well, I thought I could see a graphical representation, but I can't. But I thought oh, maybe because I have to select a physical member. Ah, there it is. Okay, so if you added just a member load, you could just take your beams cursor and double click on it. Mine has a physical member assigned, so if I take my physical member, double click on it, I can go to this loading area and I can see a little bit more information on that. I was kind of hoping I'd get a graphical, but I don't. So, but I can get more information if you want to kind of query around to make sure.
Okay. Are those 6 load tests that you have over there, are those based on last year's bridge?
Yes.
Or those this year's?
All of the materials were actually, there was very little difference between the materials, the rules between last year and this year. The main thing being your dimensions of your bridge have changed a little bit and your load magnitudes and locations. So definitely refer to this year's loads for any of that. And for any type of guidelines, you always want to refer to the rules and not necessarily literally.
Yeah. I was just, you know, based on what I was looking at, I just see that there's multiple cases of where they're going to test deflection, but it seems like they say the grates that they put on there are a set size, and the ends will be put abutting at 9'9" from one end. So it seems like there's only one load case. But you know, I didn't expect you guys to really have that operate. So.